You now have seen some peculiar drag phenomena. At this stage, things seem complicated. But actually, there is structure and order to everything you see and will see. Can be explained through the physics and principles of fluid mechanics. We have here two objects. One is a ball, one is a cylinder. We know that the drag of these two objects is different. As they pass through a fluid, their boundary layers will interact with the fluid. We will now make a small demonstration. As young scholars, we are taught to neglect the effects of air when examining the trajectory of a projectile. But actually, air is very important, and it has a big effect on the path of an object. We see now a ball of significant mass, and when I roll it down this incline, we get the expected parabolic path. Now, I will do the same with a cylinder, lightweight, less than a gram. Now, we will roll it, and as it rolls, it will pick up some speed. The cylinder falls backwards, not in the parabolic path. What happened here? This is called the Magnus force, and we will explain it now. We saw that when an object is given spin and traveling in a certain direction, it will interact with the fluid in which it is traveling in. Due to the rotation, we will get a pressure gradient on the wake of the object, and this pressure gradient will create a force known as the Magnus force. So here is a small cross-section of our cylinder. Let's say the cylinder is falling down. As it falls down, it will encounter the fluid, which is air. Now, since the cylinder was rolling off the incline, it will have a spin going this way as it falls. When the air hits the cylinder, a thin boundary layer will form around the walls of the cylinder. Air going in the direction of the spin will come out and accelerate, and will stick to the boundary layer for longer and will curve. Air meeting the opposing rotation will slow down and go around the trajectory of the cylinder. On the wake of the cylinder, we get a net airflow going in this direction, which will create a pressure gradient. According to Newton's third law of motion, for every action, there must be an equal and opposite reaction. Thus, the ball is forced this way due to the pressure gradient. See, it is simple when we understand the laws of fluid mechanics. We now see that indeed there is no magic to a curveball. It can all be explained through the laws of motion of Newton, and it can be explained through the complexities of fluid mechanics.